Welcome to the Explainer. Today, we're going to do something a little different. We're not just going to talk about cloud computing, we're going to become digital real estate developers. So grab your virtual hard hat because we're about to build, scale, and secure our own digital properties. And our main toolkit is Google Compute Engine. So let's just try a little thought experiment. For the rest of this explainer, I want you to forget about being an engineer or a developer. Nope. Today, you are a digital real estate developer. Your job, to build and manage a sprawling digital empire. And the company providing all your tools, your materials, your heavy machinery? That's Google Compute Engine.
All right, so every good project needs a blueprint, and here's ours. We're going to start small, laying our very first foundation, then we'll expand that into a whole city, make sure it's secure, keep an eye on the budget, and finally, cover all that crucial day-to-day maintenance.
Every massive skyscraper, every huge development, it all starts with laying down those first few bricks. And in our digital world, that very first fundamental brick is what we call the virtual machine. So what are we even building with? Well, the main thing is the virtual machine, or VM for short. Just think of this as your customizable building. You get to decide how many workers it has, that's your CPU, and how much workspace they have to operate in, that's the memory. But of course, every building needs a plot of land to sit on, right? That is your persistent disk. It's the ground beneath your building where all your data, all your stuff is actually stored. Okay, so you've built your first property, and your first tenant, let's say a really popular database, is already running out of room. They need more storage. Now, in the real world, buying more land and expanding a building would be a nightmare. But in our digital empire, it's shockingly simple. So how do we do it? And this is where things get really cool. This is a killer feature of Compute Engine. You can actually resize that plot of land, the persistent disk, while the building is still running. You literally just go into the Google Cloud Console, drag a slider to increase the disk size, then you pop into the machine and run a quick command to let the operating system know, hey, you've got more space. And that's it. More storage, instantly. No reboot, no downtime. This is an absolute game changer.
So one building is a fantastic start, but let's be real, we're trying to build an empire. What happens when a flash mob of customers shows up at your door? Or what if a digital earthquake happens and takes out the entire neighborhood? We've got to think bigger.
This is where your business really starts to take off. Your application is a hit, but now during busy hours, people are complaining it's slow. The solution? It's called a managed instance group with auto-scaling. I want you to think of this as a master blueprint for your building. When a huge rush of visitors comes, this system automatically uses the blueprint to construct new, identical prefab buildings to handle the load. And when everyone leaves, poof, those extra buildings are automatically taken down. It's totally efficient, totally responsive, and best of all, completely hands-off for you.
Okay, but with all these identical buildings popping up, how do your visitors know which one to go into? Well, that's the job of the load balancer. It's like a friendly traffic conductor standing out front. It sees each new visitor and points them to the building with the shortest line. But crucially, it does something else. It performs health checks. It's constantly tapping on the door of each building asking, hey, are you open for business? If a building doesn't answer correctly, the load balancer immediately stops sending people there until it's fixed. It's absolutely vital for making sure your users always have a smooth experience.
Now for the ultimate test. Scaling for traffic is one thing, but what happens when the very ground beneath your buildings just disappears? A whole data center, what Google calls a zone, suddenly goes offline. Everything you built in that zone is just gone.
This is where you go from builder to master architect. By using something called a regional persistent disk, your plot of land was secretly being copied, in real time, to another nearby zone, the whole time. So when Zone A goes down, your master blueprint automatically kicks in and builds a new building over in the healthy Zone B. And then, and this is the magic trick, that brand new building just attaches to the perfectly replicated plot of land. And just like that, you are back in business with all your data safe and sound. We're talking minutes of downtime, not hours or days.
Okay, we've built a city that's not only big, but it's resilient. It can handle anything. So what's next? Well, now that you've got all this valuable property, you gotta protect it. So let's talk about the fences, the gates, and the security guards.
Now, two of your most powerful tools here are firewall rules and something called Identity-Aware Proxy, or IAP. Think of firewall rules as the main gatekeeper for your entire property. You get to be the bouncer. You decide exactly who and what gets in or out. But then there's IAP. Imagine you need to let your janitors and maintenance staff into a secure building, but you don't want to give them a key to the public front door. IAP is like a secure, keycard-only back entrance just for them, based on who they are. This way you never have to expose your important management stuff to the whole world.
Building all this stuff is fun, but let's be honest, it isn't free. A truly successful real estate developer is also a really smart financial planner. So let's talk about managing the budget for our growing city. This is all about picking the right tool and the right price for the job. See, not all buildings need to be a 24/7 high-end corporate headquarters. For those critical, always-on applications, you use standard VMs and you get a huge discount by committing to use them for 1 or 3 years. But for other jobs, like maybe some late-night data analysis that isn't super urgent, you use spot VMs. Think of these as a cheap hot desk you can rent by the hour. They offer incredible savings, but, and here's the catch, you could be asked to leave with very little notice. So they're perfect for any work that can be paused and restarted later.
And, the savings here are not small. They can be absolutely massive. If you look at this chart, our normal on-demand price is the baseline. Now, those committed use discounts give you a really nice price cut. But then, look at spot VMs. For the right kind of job, you could slash your compute costs by up to 90%. 90! It really shows that choosing the right building type is just crucial for keeping your costs down. All right, we've done it. Our city is built, it's secure, and it's cost-effective. But the work is never truly done, is it? Just like physical buildings, our digital properties need constant maintenance, regular upgrades, and someone keeping an eye on things.
So here's a quick look at your property manager's toolkit. For daily backups, you've got Snapshot Schedules. It's like having a photocopier that automatically makes a copy of your land deeds every single night. For safe app updates, you can do what's called an opportunistic rolling update, which is clever. It only uses your new blueprint for any new buildings, leaving the old ones alone. To track all your costs, you use labels and billing exports to get an itemized receipt for every last brick and worker. And when something inevitably breaks, cloud logging and monitoring are your security cameras and activity logs, showing you exactly what went wrong and when.
And there you have it. Let's just step back for a second and look at what we did. We went from a single, empty plot of land to a fully designed, resilient, and secure digital city. You now have the fundamental blueprint for being a successful digital real estate developer with Google Compute Engine.
So the big question is, what's next? Because what we've built here with Compute Engine, that's your flexible foundation. But on Google Cloud, you could also build a self-constructing skyscraper with Kubernetes, or maybe even a temporary, serverless pop-up shop with Cloud Run. The foundation is solid. The choice of what you build on top of it, well, that's entirely up to you.